I'm Professor John Santiago, and here we'll introduce the concept of differential equations. Now, the words differential and equations certainly suggest solving some kind of equation that contains derivatives. And indeed, one of your tasks in this course will be to solve equations for an unknown function. And you will see as the course unfolds that there is more to the study of differential equations than just mastering methods someone has devised to solve them. But first things first, in order to read, study, and be conversant in a specialized subject, you have to learn the terminology of that discipline. And this is the thrust of the next couple of sections that we'll be talking about here. So in here, we'll briefly discuss the link between differential equations and the real world. That is, practical questions such as, how fast does a disease spread? Another question may be, how fast does a population change? All this involves rate of change or derivatives. And so the mathematical formulation or the mathematical model of experiments, observations, and theories may be a differential equation. So first, let's look at an example before going into detail the definitions and terminology. Let's say we're given a function y, which is equal to e raised to the power of 0.1 times x squared. And let's take the derivative of this. And we'll define this function phi of x. So y is equal to phi of x. Now, what is the derivative for this function? Well, simply, when you take the first derivative, we can use the chain rule. So here, we take the derivative of this power function. So that's just 2x times 0.1. And then it's just simply the same function, e raised to the 0.1 x squared. But we note that this is defined as y. So we can rewrite this equation dy dx as 0.2, that's a result from multiplying 2 and 0.1, that's where the 0.2 comes from, and then multiply by x and then multiply by y. So given this equation now, right here, what is the function y? Well, we did this almost reverse engineering sense where we'd already defined y, but that's the solution to this equation. So how do you solve this equation to find the unknown y? Well, that's the purpose of this course. Once again, this is what we mean by a differential equation. Unlike in algebra, we're trying to find the values of a particular x and y in an algebraic equation. Here we're trying to find a function. So let's look at a definition of a differential equation. An equation containing the derivatives of one or more dependent variables, in our previous example that's y, with respect to one or more independent variables, and in the previous example that's x. So dy dx is equal to 0.2 times x times y. We see here that x is the independent variable and y is the dependent variable. Usually when we're dealing with functions of time, t is usually independent. Once again, y is the dependent variable. Now let's look at classifications of ordinary differential equations by type. So what is an ordinary differential equation? This occurs when an equation contains only derivatives of one or more dependent variables with respect to a single independent variable. Let's look at some examples. So here's dy dx. Y is the dependent variable, x is the independent variable. So here dy dx plus 5y equals e to the x. So here's our derivatives with respect to a single independent variable, and in this case it's x. Another example, the second derivative of y with respect to x minus dy dx plus 6y equals 0. So we have y, dy dx, and the second derivative, all with respect to a single variable x. Now here in this case we have first derivatives dx dt plus dy dt with respect to the time variable equals 2x plus y. Again, this is a differential equation that is ordinary because it's only with respect to a single independent variable, and that means t is that single independent variable, although we have more than one dependent variable. In this case we have two.
Engineering videos, step by step. So visit freedomuniversity.tv now. Learning engineering just got easier.